Um, okay, so let's talk about layer three and what's it all about. Um, well, the main thing I want to get across to us is what you're gonna cover in chapter 4. I mean, excuse me, chapter 6. What you're gonna cover are these 3 items. Well, really 4 items. If you can see the screen, you will talk
Yes.
about the protocol itself, which was the layer 3 protocol, network layer protocol. We'll talk about routing and how does this equipment actually route data. Then we'll talk about the routers, the actual equipment themselves, and there's really 2 main pieces of equipment in layer 3. And that's the switch and the router.
Mm-hmm.
And then we will talk about how to configure a Cisco switch. Now there are about 9 or 10 other kinds of switches out there. I mean, it's not I mean, it's Cisco router, excuse me. And don't get don't get the little routers we have in our house in the home confused with a true router. As a matter of fact, even though we call them routers, they're not really routers what we have in our house. They really are not. They really are. They're called network access devices, and they just allow us to put uh, several types of equipment, like a printer or a laptop or other home office equipment. It allows us to put that on one line going out to the true network.
So it's
Uh,
like a WAP.
Say again.
It's like a WAP,
Yeah, well, that WAP is the
wireless
type
one.
of the is the type of encryption that's placed on the network. But all of these things that like my little box up here that is it's a Comcast box, but it's not really a true router. Now there are some in-home routers. You can have a true router. And I mean, if you got a let's say a T1 or a T3, well, you learn about those later on. T1 or T3 line coming into your office or your home, you may have a true router sitting in front of it because that router's got to break everything down to packets before it sends it out. Uh,
Mm-hmm.
but the things we have in our house are not really routers. But anyway, we're going to talk about routers and how to configure a Cisco router. All right, let's get going. Uh, okay, let's talk about the network layer protocol itself, which is the layer 3 on the OSI model. It's layer 3, and and what does the OSI layer 3 protocol does? Basically, it provides services that allow the end-to-end or end devices to exchange data completely across the network. So, and the most important thing that it does this without regards to what type of media that those devices are on. So that's why you can have your cell phone on your Wi-Fi at home. You can come home and plug your cell phone to your Wi-Fi and keep right on going. Cause the layer 3 doesn't care whether it's a actual computer plugged into it or whether it's a radio plugged into it. It doesn't care. It's gonna take that data and encapsulate it. And speaking of encapsulation, those are the 4 things that the layer 3 devices do. Now we know that layer 2 also encapsulates, but layer 3 is taking what layer what layer 2 has. And I mean, before at least before it get to layer 2, now understand all this stuff is going backwards. It's coming from layer 7, and then before it goes out, it's on layer 2. So
Wait, is this the same thing that Ethernet is on?
and layer 2 is Ethernet. Layer 3 is not Ethernet. No.
Oh,
Yeah, we just finished. That's how we called it Ethernet. The last chapter we covered was called Ethernet.
mhm.
And the reason it was called Ethernet is because it's layer 2. It's more concerned with with media. but but layer 3 takes it from the transport layer, and then it encapsulates, puts its own encapsulation on it. But more importantly, and this is what's so very important about layer 3, once it encapsulates it, it now routes it. It's the one, that's why it's so important, because it's routing that data to where it's got to go. So it's the one that's putting the addresses on it, the source address and the data address, and the and put all everything that's needed to make that to address that message to get to where it's got to go. And that's the most important thing about layer 3 and what it does is routing. Layer 2 doesn't route. Layer none of the other layers actually route. None of them do. Only layer 3 does the routing. Okay. So one of the questions that was asked us is, what characteristics of the network layer let you carry packets of different types on many hosts? And we just described that. We just described that the network layer protocol specifies the packet structure and processing used to carry the data from one host to another. And the important thing, it specifies the structure, which is a packet, and the heading needed. Okay, so now, what are some of the characteristics of IP? What is IP?
Internet protocol.
Right, Internet protocol. That's really kind of double word they use. They shouldn't say IP protocol, but that's okay. We all know what it means. But IP is the Internet protocol, or putting it on the Internet, which is a packet protocol, basically. And the most important thing about it is that these packets are delivered completely out of order. They're torn apart. That message is torn completely. You may have the first packet that went out on your message, maybe the last packet that MacArthur received when he gets your message. But it has to take them and put them back together in order. And those out of order packets are delivered, and then the application using the data or the upper layer. And here's what's so important about IP is that it allows them to be very, very efficient. It's not worried about a reliability. It ain't worried about, did I get it there right? Because it's letting the other layers make sure that the message is right. Either layer 4 or layer 5, 6, or 7 will make sure that it got the message right. So Internet protocol is not really that concerned. That's one of the big characteristics of IP. And there are other characteristics, but that's one of the big ones. It's called best effort delivery. Best effort means I'm not concerned about how it gets there. I just want to make sure that there's no guarantee that the delivery is going to be made it's just getting it efficiently. And another thing about it that it's media independent, which means that IP does not care whether you do it on fiber or you send a message on radio. It doesn't care. It's media independent. Another very important thing. You guys are going to get into this in one of your next classes. That is connectionless. And what does that mean? That means that you never really establish a connection. If I got a session going between me and MacArthur, and we have a audio session going, and we're talking to each other, there was never a real connection ever established between us. There is no hard wires or hard radio channel that's set up that he and I are dedicated to talking on that channel, talking on those wires. Never one connected. In fact, while we're talking, our package, some of my package right now, talking to you guys up there in New York, my package may go all the way out to California, come back before they get to New York. There's never a true connection set up between us. Now there was a session set up between us. There is a hard session between me and MacArthur, but never a connection. That session means that in this space and time, his end's connected to his end, and my end are always sitting there. How the data flows between them is not connected. It's going everywhere. Hope you understand that, but it's called a connectionless protocol. Okay, and we talked about encapsulation.
Yes, sir.
Encapsulation is basically, like we said, it's encapsulated into a packet now. What was layer 2 encapsulated into?
You said what?
What type of PDU was layer 2 data encapsulated in? What was it called?
Was it frames?
There you go, a frame. Very good. Yep. Layer 2 is set up on frames. That's correct. Okay. All right. So you need at least know those two things, guys. If you don't know much about what kind of PDU is on the transport or all this good stuff, but you need to know at least that on the media, layer 2 is a frame, and on the network, layer 3 is a packet. Okay.
Yes, sir.
All right, we're gonna move on. Now, you see this picture on there? Make sure you all understand that picture. Those are the characteristics of IP. Everybody seen it? Encapsulating IP, connectionless, best effort delivery, and media independent.
Yeah.
Okay. All right, we're gonna move on now. Okay, the question was asked, how is missing data detected and retransmitted for a connectionless protocol? And that's really, we just covered that, as a matter of fact. We'll cover it again. We just said that the main thing about how that data is not done in the IP protocol, it's done in the upper layers protocol. They're responsible to make sure that that data is retransmitted, or that it is if I got some data on my computer screen, my application got to say, this is not good data. You got to go back and say, retransmit the data for me. So it depends upon your application layers and your upper layers, your transport layers. They're the ones trying to make sure that you got good data. But the IP layer is not. It's not worried about it. Now we're going to get in. Now there is a packet layer that does. I mean, there is a packet protocol that does worry about that. We won't talk about it today, but just let you know there is one out there, and it is concerned with whether or not you got good data or not. But that you only use that particular IP protocol when you don't care about the speed of the data. You really don't care about it. You just want good quality data. And we'll talk about that later on, but not right now. Okay. Next question asked us was, what is the function of the TTL field of the IPv4? Okay, you guys need to make sure y'all understand this one page. Understand it inside out, upside down, backwards, forward. This page that we're looking at now is called the IPv4 packet header. It tells everything that's in that header. That header is really identifying that we got a packet. You got packet data coming behind it. Headers are so important. A header in the frame will tell you whether or not you got a frame of data coming. So when that device, whatever it is, sees that header, says, oh, this is a frame coming in. Ah, okay. It knows what to do with it. It'll just pass it right on through, does nothing to it. Or if it's an IPv4 packet, it knows I got to tear this down. I got to decapsulate it and take the data out and do something with it and put it back together. It knows that this is a header. I mean, a packet header. So you need to know this packet header and every field. That's the thing about every type of data unit is divided into fields. Just like there are different fields in your your different MAC headers and your frames. They have certain fields divided in the header. Same thing is true of the packet header. It's divided into fields. You got to know each field's got a function. Each field has a function. The first field talks about the version. Is this the IPv4 or IPv6? So it tells you which version that particular packet is. That's important because whatever kind of equipment you're going over, it's got to be programmed for either IPv4 or IPv6. It has what is called a diff serve or differential of service, which tells the type of service that packet is actually providing. The quality of service, and it tells the different type of service that packet is provided, whether it's going to be priority service. So that's in the DS or the diff serve field. Then you got the next field. It's called the time to live. That time to live is one of the most important fields in there, because that time to live says, look, this packet may have been floating around the network for for 20 milliseconds, and it was just a runt. It was a collision packet, and it has no purpose. It's just out there. So rather than let it just keep floating around there and messing up stuff, it dies. It just goes away. It literally goes away. But that is set up. You can set that up in your routers, how long you want that packet to live. So if that packet hasn't got where it's supposed to get by a certain amount of time, that bad boy just dies. But that's called time to live. It's an 8-bit binary value, and that is another field, a time to live field. Then we got the protocol field, and the protocol field. That's what I was telling you guys about the different protocols on in the IP protocol. There are about 3 different IP protocols. One is called TCP, one is ICMP, and one is called UDP. And UDP is what I was telling you about. That's the one that want to make sure that the that the data is good. TCP don't care. TCP say put it out there and put it out there fast. But UDP wants to make sure that you got good data. ICMP is really more concerned with email type data, so it doesn't really care either. It's worse than TCP. But those are the 3 kinds of protocols that are on the IPv4 IP header, and it's got to tell you which one it is. Okay, then you got the source address and the destination address. That's also in that header. So all this good stuff is in your v4 packet header. Need to know that. Need to know that. So somebody tell me real quick, what is the function of TTL?
TTL.
Just covered it. Let me back up so you look at it.
It drops the packet if it don't if it never sends in time.
Yep. If it never gets there in time, it's called time to live. If that packet never gets there, or that message never get there in time, or we write the packet. It's not a message, it's a packet. If that packet don't get there in time, before that time to live expires, that packet goes away. It dies.
Sure.
So that's TTL. Okay. Another question that is asked is, what is the function of the protocol field of the IPv4? Well, you guys just saw that. I'm not gonna go over that again. We just talked about the UDP and TCP and ICMP. So you need to know that's what that field does. Which protocol is in this packet? Okay, the next question asked me was give me what are some of the advantages of IPv6. So let's cover that real quick. Here's some of the major advantages of IPv6. 6.1.4.3. The biggest one is that it has a much simpler header, and because it's got a much simpler header than the IPv4, then it's going to transmit a lot faster, and it's going to be a lot more efficient. So IPv6 does transmit a lot faster, and it is a lot more efficient. There's no need. I'm not going to get into what NAT is, but it eliminates the need for NAT. We'll talk about that a little later on. And here's the biggest, probably one of the major advantages of IPv6 is IPv6. IPv4 has a 32-bit 32 bits of information in the header. 32 bits. So that's telling you, it tells you that you can only have so many addresses out of 32 bits. 2 to the 32nd power, which is 4,290,000. Is that right? It's 4 yeah, million, no, 4 billion, 294,967,296. That's not, you think there'd be a lot. You think that's a lot of addresses. It's not. That's the problem with IPv4. It's running out of addresses. We don't have enough address for everybody that wants an address. So that they come up, as you guys will see, there are all kinds of ways now of doing. There are all kind of dynamic addressing and things going on to be able to allow you to reuse and reuse and reuse the same address over and over and over again. Because there's just not enough addresses for all the demand on the internet.
So they skipped IPv5.
Huh?
They skipped IPv5.
In a sense, they did. Yeah, there was no IPv5. There was another. There was another design, if you will, to try to, but it never did get off the ground. So it never did really happen. And IPv6 was the one that came up that said the version 6 was the one that really was adopted. And we were, there's a whole history on packet switching and a whole history, and I'm sure that's in one of the books. That I really didn't get into it that much, but yeah, there's a history on packet switching, and tells how they went from 4 to 5 to 6, and how 5 never really dropped the ground. But IPv6 version 6 has, and there's such a number, guys. Everybody gets stuck on trillion. There's a number called a udecillion. Yeah, I mean, one day I'm gonna bring you guys in a table that has all the numbers that go past. That everybody talking about zillion. There's a number above zillion. In fact, udecillion is way above zillion.
Dang, how many zeros is that?
Oh man, look, there's numbers right there in front of you. If you're seeing it, it's 340 udecillions.
Dang.
And they try to give you an idea of what that means. Is that there's enough addresses to be able to address every grain of sand on the earth. All over the whole earth, not just one beach, not just one desert.
The whole earth.
Every grain of sand on the whole earth. That's a lot of addresses, man. And that's what IPv6 does. We probably never get to IPv7 unless somebody tries to start addressing every grain of material in the whole universe.
They better give us an IP address.
That's the purpose of IPv6.
To give humans IP addresses?
Yep. Every human have their own IP address. Your shoes have IP addresses. Somebody stole your shoes. You will know your shoes.
You can track them.
You can track it. They can't. They won't be able to steal your shoes anymore. So get an address. Hey, you got on my shoes, buddy. It's got an IP address on it. Yep. So now you gotta see where it's going. It's gonna put a lot of thieves out of business, man. But yep, that's where it's going. IPv6. Everything has IP address on it. Everything. Okay. So those are the big things about IPv6. Okay, it asks the question of how do you identify a routing decision on the routing table? Okay, guys, this is going to be probably one of the big deals you all are going to cover here. Is we're getting into routing tables. Now we're talking about how things are actually routed. Any kind of computer host, whether it's desktop, laptop, pad, whatever, any kind of computer is considered like a host. And that host has the ability to set up a route or a routing table of how it's going to route the data coming out of it. You can either route that data back to itself, that's called a loop back, and there's one specific, please learn this address. Learn this address because you're going to hear it a million times. What is 127.0.0.1? 127.0.0.1. That's called the loop back. And if ever you get ready to test a data link, you got to be able to set that source address as 127.0.0.1. So it'll loop back on itself. So it'll test itself. So it can send data back to itself. It can send data out on the local. Now, what do y'all call the local network? LAN, thank you. They're out on the LAN or a local area network. And usually a LAN is talking about a network that is usually all of them plugged into one switch. I mean, sometimes you can have more than one switch, but usually it's one switch, 24 ports, defined for a local area network. And usually, once it goes to a router, it now is getting ready to go out to a. Now you can have. Don't get me wrong. Don't hold this firm. You can have routers in local area networks too. But anyway, that's usually considered going out to a remote network. And that route is usually dedicated to one specific local area network. But it also has other networks or other routers coming into it. So that's saying it's going to another remote network. And just because it's a remote network doesn't mean that it could be on the same campus, but it's considered remote because it's going to another router, a different router, router 2. So that's the three big decisions that got to be made whenever you're forwarding a message. Is it going back to itself? Is it going out locally or going out remotely? The other big important thing is talking about the default gateway. Every router, not every router, excuse me, but every switch and every host got to have a default gateway plugged into it. And what is that default gateway? Let's find out what it is. So important to know this. Well, let's talk about, before we get to that, let's talk about the routing table. There are two kinds of routing tables. One that's going to be in the host itself, and that's the actual host routing table. And then there is the routing table that's going to be in the router itself. That's called a router routing table. And they got basically almost the same information in them, but they look different. We're going to talk about that in a minute. The two kinds of routing tables, and all a routing table is basically a routing table is just a table that shows everything's attached to that particular to that host or to that switch or to that router. Everything is just attached to it, and where it's going to be sending information out to. What information, all the possibilities that information can be sent to is in that routing table. And you're going to learn that there are some networks in the routing table that are called directly connected. which means these are directly connected to that switch, or to that host, or to that router. They're directly connected. And then there are other networks that are called remote routes. They come from another router somewhere else, and it learned about those. We'll talk about those learning. They're learning protocols called EIGRP. We're going to all different learning. You're going to know that in the next course. But there are learning protocols that allow that router to learn that there are other networks out there that it can send stuff to. And those are called remote networks. And then there's called the default networks. The default networks is like almost like a default gateway, but it's a network setup that broadcasts everything. And why it does that is because before a data stream dies, before the TTL runs out, the default network says, okay, send this thing somewhere. Send it to everybody. Say, do y'all know what this is? And everybody says, I don't know. Let it die. So it's trying to send it out to everybody to make sure that before it dies, that it had a chance to get to its right place. That's called the default route. And almost every device got either a default gateway or a default route. Every router or switch got a default route. Okay? Make sure you know about those. Now we talk about the this is the PC routing table. Let you guys look at this real quick. And this will be on 6.2.1. This is a PC routing table. Let me blow it up real big so you can see it. This PC routing table, the difference between it and the routing table is that the PC routing table has heading descriptions. But it has description of the account information in each column. It has column headers, and it will show you the network destination. It shows you the network net mask. We're learning about net mask. It shows you the gateway, and this is not talking about a default gateway. This is talking about the gateway of what actual port does the data go out of on this route. And as you notice, it only has only one gateway, which is the port that this and every port. Now, you understand is every port on a host has an IP address on it, and that's why you see that IP address is on that gateway or the interface. And then of course there's the interface itself. The interface itself. Well, no, I got that wrong. Let me get that back right. The gateway is your actual default gateway. The interface is the port that your data is going out of. So that 192.168.10.10 is the interface. Whatever the interface is, it can be Ethernet interface, but that's the port that your data is going out of, the exit port. The gateway is looking to find that gateway, and that gateway might be on a switch out there somewhere, but ultimately, that gateway is going to be a port on a router somewhere. That default gateway is going to always be a port on a router where it's trying to get it to. And so So that's the primary difference is that it's saying every host got to have a default gateway, so that it will know that, okay, here is the port that's going to go out of on the router, and anything going out of that port is going to another router somewhere else. So if this message got to go to a somewhere outside of my local network, I'm sending it to the default gateway. That's where it's going. So it can go out to another router. Does that make sense about default gateways?
Yes, sir.
Yes.
Okay, so that's the main thing it's looking for. It's looking for, I mean, the main thing you want to see is that they're organized. They're just organized different. The data, the information on this PC table is organized different from the information on a routing table, router routing table. That's the main thing we want to see. Okay, let's move on. Okay, let me bring this back down so we can read it. This is okay. Our routing router table. Whenever you get into the Cisco iOS, if you type in, you guys probably used to this by now, but if you type in the command show IP route, it will bring up the routing table, the IPv4 routing table. And that's how you can tell. Now that it's almost like a doctor taking an X-ray. Okay, you got the X-ray, but everybody can't read X-rays. You know, they don't know what they say. Oh, it looks good, but what is it saying? What is it telling me? And that's where you guys can make all the big bucks. Y'all make the big bucks from knowing how to read a host routing table and a routing table, especially a routing table. By all means, make sure you see this video says 6.2.2.3. There's a video on the IPv4 routing table. Go through that video 2 or 3 times. And make sure you understand how to read and what's in a. I'm gonna give you a quick little dose of it right now, but make sure you understand how to read an IPv4 router routing table.
All right.
Let's go over real quick what's on. Let's see. Here it is right here. Okay. This is what you're going to see on most of the routing tables. You will see at the very top of the page, you'll see at the top of the screen, you'll always see a code. I mean, it'd be like a code directory. It tells you what those codes mean, whether it's EIGRP or what does it mean. But it'll tell you what the codes mean. And there's 3 primary codes you want to know. And the 3 codes you want to know is what is meant by C. The C code is directly connected routes. They are directly connected to that device, or to that switch, or to that router. And you want to know those because that tells you what's actually physically connected to that router by cables, by wires, physically connected. Then the D code is telling you what is remotely connected. That means it had to learn that from somewhere else. You had to go out there and say who are you and where and where are you at, and it's all okay. You're outside of my network, okay, but I've just learned who you are, so now I'm gonna put you in my routing table. And I know who you are now. And that's what EIGRP. That is a protocol that helps it learn who these other routers are, where they are, what they're doing. So you believe me, when you guys get into those learning protocols, you're big time now, man. But y'all will learn them. You'll learn all the different learning protocols. But D is a remote routing table. indicates remote. And the last one is S. S indicates a default route. Usually some type of default route is indicated by the S. Now don't, okay, this is, come on. Let's get back to that again. Now, one thing that's left out of here, they should have put in here, is the L. L is the local link network, and that's also a directly connected network, but it's set up as it can be a local link between this router, between this device and another switch, or there can be two switches on it, but usually local link is also a directly connected route. So you're gonna have really four kinds of routes that are gonna be categorized: C, D, S, and L. And get used to those because they're gonna be in that routing table. Now, since on the PC routing table, we just talked about that. On a PC routing table, look for the destination network and the exit port IP address. Those are the main things you want to find when you're reading a PC routing table. Because it's going to tell you, let me say that again, always look for the destination IP address and for the exit address. Let's load this up one more time so you can see this. Oh, come on now, thank you. All right, we're going back to a PC routing table. You see where it says destination?
Mm-hmm.
That destination is telling you the destination addresses that this PC has in its table. And these are all the different, destination addresses. And then it has, well, all the different net masks. We'll talk about net masks a little bit later here. Then it has the gateway and the interface. The interface is telling you where, that's the exit interface. And if you notice, almost all these main destinations are going out the same, they're going out of the same interface, except for the ones that are loopback. 127.0.0.1. If they're not loopback, they're all going out of 192.168.10.10. All of them. So that tells you that that is the exit interface, that everything from this PC is going out of that interface. That is the main interface that everything exits out of. Okay, now it may be going to a loopback. The destination may be a loopback, or it may be going to this 127.255.255.255. It may be going to 198.168.10.225 or 255, but that's where those packets were destinated to go. But they're all coming out of, and you can almost say that interface is a source address. It usually will be the source address for that PC, but it's telling you that's where it's going to leave out of the PC. Do you guys understand that? Because those are two most important things you need to know. Because they're going to probably ask you a lot of questions about how do you where's this packet going, and what's the two most important things you need to know about that table: source addresses and your destination or the interface that's going out of. As far as the PC is concerned, that is the destination. Excuse me. That is the source. Don't let me get mixed up. That is the source. That's where it's going to exit out of from the PC. But it's going to be sent to one of those destinations. Okay, you got that? Because that destination, what you're going to need to know, that destination, it may be another PC that is going to, it may be a switch is going to, it may be a router is going to, but that's the destination it's trying to send that message to.
All right.
Okay?
Yeah.
I took a long time on that because that can get to be very, very confusing if you don't know how to read that table. And also very confusing if you don't know how to read a routing table. Okay, let's move on. We talked about router tables and PC routing tables. Okay, let's get into this. What type of routing table entry has a next hop address? Let's find out about next hop addresses. Okay, and this is really 6.2.2.6. The next hop address is when a packet is destined for a remote network. When a packet destined for a remote network arrives at the router matches the destination network to a route in the routing table. If a match is found, the router forwards the packet to the next hop address out of the identified interface. So that next hop, basically in a router, is saying, where do I send this packet to get it out of my router, to have it go somewhere else? And that's the next hop is simply saying that is a port, just like the PC got a port that all its data goes out of. The router got a port that all its data goes out of to go to another router. And if you got, let's say you got two routers connected to this one router, then you may have two next hop addresses. But that next hop address is going to be the next address where the router will send the data to get it out of its router to another router. Now, does that make sense? Because that's you need to know what a next hop address is. We're going to talk about it. And we talked about this already. Notice how directly connected networks with a router source C or L have no next hop address. Why do they have no next hop address? If it's got it directly connected, or it's got a or it's got an L, local link. And because that's exactly why it is these lines are directly connected to the router. They are not lines that are set up to go out to another router. These guys are all directly connected to this router. And so there will be no next hop address associated with them. But if you got a route that has a next hop address, then that route is looking to send data outside of the router to another router. And I beat up on that enough. I want to be sure you got that.
Yeah, got it.
Okay.
Yes, sir.
All right, now let's go into how a router looks on the inside. And I'm going to defer this one here again to there's a diagram on 6.3.1.5 that shows all the different connecting ports to a 1941 router. And 1941 is not a year. 1941 is the actual nomenclature of a Cisco router, probably one of the later routers. So you need to kind of understand that 1941 router and all its different features Make sure that you know those features of the 1941 router, and the different ports coming off of the 1941 router. Like I said, if we had a lab this time, you guys would physically get a chance to go in and play with a 1941 router and actually see the ports, physically see the ports, physically see the different RAM and the ROM and the flash drive and all, the flash memory, all that good stuff. You'll get a chance to see it. But for right now, you just got to look at the picture and hope you can understand what the picture is saying to you. And speaking of that, we just talked about what's in the RAM of a 1941 router or any Cisco router. What's in the RAM? The RAM stores the actual application process and the data needed to execute. Need to be executed by just like any RAM. If you are working on something, and that's why it's called random access memory, it's because our random access memory is volatile. What does volatile mean, guys?
It means you can
If
erase.
you shut it down, it won't save.
Yep, it won't save. It goes away. It blows up. That's why it's called volatile. It blows up. It goes away. It destroys itself. You guys remember seeing that Mission Impossible, where he said that this tape will self-destruct in 3 seconds after you get it. That's exactly what a random access memory do. It self-destructs once you shut it down. But it's used only to process stuff. If you want to calculate 3 times 5, it'll be in the random access memory, unless you save it. So save the result somewhere. It's gonna be in it, then it's gonna go away when you get to calculating. So that's what it does. It executes stuff for the CPU. ROM is non-volatile memory, and the ROM stores crucial operational instructions. It also stores a very limited backup IOS, which was the operating system itself. But it stores crucial operating instructions, stuff that you don't want to, like for example, when you get ready to type in a copy command, copy run start, you want it to always be there. You don't want it just to self-destruct. If it self-destructs, then every time you get ready to start your computer up, you got to go back and reload the iOS all over again to get those commands every time. That ain't good. So it has very important operation instructions that it don't want to lose. And some of the commands you don't want it to ever lose will be in the ROM. Always be in your ROM. Let's see. NVRAM, which is non-volatile RAM. That's an oxymoron almost, but it is RAM that is non-volatile. It's called NVRAM. But NVRAM is really used to store your startup configuration. So that once you configure that router, you don't want to lose that configuration. You don't want to reconfigure the router every time you bring it up. And that's what NVRAM is for. You don't want that. You want to be able to change it if you want to change it, but you don't want it to be lost just because the computer powered down or whatever. You want it to always be there. And that's stored in NVRAM. And then we come to the flash, which is also non-volatile. And the flash memory is where your iOS, the main iOS, is stored. Many of your log files, like your some of your configuration files, your backup files, they'll all be in flash. Flash is not very big, not a lot of memory. but you still want enough memory to store your iOS. I mean, that's where whenever you get ready to reboot your computer and bring the iOS up, it comes out of flash. And if your flash drive get corrupted, now you got to go and find that backup iOS. And where was that located?
What you say?
Where's your backup iOS located?
Backup. I don't know. Is it on ROM?
In ROM, correct. That's it. So either flash or ROM got an iOS in it. Either the actual iOS or the limited iOS. Okay, but that's the main thing you want to learn about in your now let's look at some of the interfaces, some of the LAN and WAN interfaces on your router. You need to know these too. There is the console interface, and you guys been used to setting up, logging into the console on Packet Tracer. Well, this is a physical interface that you plug a computer into, and if you were a technician going out to a site and you want to either diagnose that router or that switch, or you want to reconfigure that router, you want to plug your computer into it, your laptop into it. To do that, you plug into the console port, and you have a special a special console cable that allows you to plug into that console port. But that's a port on the router that you can plug into to do things on it. Then there's called the SSH, or the security shell port. The SSH port is where you will log into remotely. If you are trying to go into another router that's in Chicago somewhere, but you're sitting in Atlanta, and you want to get into that router, you will be going through the SSH port or the secure shell. Always got to be secure, which means it's encrypted. There's a telnet port, and the telnet port is the only difference between the telnet port and the SSH port. You can get into a telnet port, but it's not encrypted. You can dial into it or log into it from a long distance, but it's not encrypted. So your telnet port is only your port of last resort if you got to get into that bad boy, and you can't get into the SSH, or somebody that's on the SSH, you just can't get into it right now. Then you can log to the telnet port and do the same thing, but it's not encrypted. Okay, so then you got the auxiliary port, the other ports like the auxiliary port, and but you see all of these on the router, and you know which one you use for what. Okay, boot up. What is the boot up process? Every time you reboot your router, it goes through the boot up process. The first thing that it's going to do is perform what is called the post and load bootstrap program. It's going to go look for that first. And what is post and load? Post is a test that is run on it's a self-diagnostic test that is run on every router before it loads it up. It goes to make sure that nothing is corrupt in the iOS. It makes sure that the router has nothing messed up in it before it loads that iOS into the router. And it's called a post test or a diagnostic test. And that's the first thing it's going to do. It's going to perform the post test. Then it's going to locate and load the iOS. Where is it going to get the iOS?
Sorry, what you say?
Where does the router go when it's booting up? Where is it going to go to get its iOS? You guys know what iOS is, right?
Is that the NV RAM?
No.
Flash?
Flash. It goes to flash. It's going to go to the flash memory to pull up the iOS. So that's where that's the next step in the boot up process. And then the last step in the boot up process is going to go load the startup configuration. Now, what if it can't find the startup file? What does it do?
It is default gateway.
No, not default. Default gateway is when it's trying to send data out. This is just when it's just booting up, like booting your computer up. It says it right there. What is number 3?
Locate and load the startup configuration file or in the setup code.
Setup mode. It goes into setup mode if it can't find that file, because now it's going to allow you to go somewhere to find that startup file, and that startup file usually going to be in a in NV RAM. It'll let you go out there and find that startup file to load it yourself. But I mean, setup. I mean, it goes into setup mode to let you go in and set it up right. And setup mode is a lot of work. You don't. I mean, you want it to load itself up, but if you got to go load it yourself, then you got to do all the good stuff to set it up, set the computer up yourself, because that means basically that it couldn't find the startup file. So it's going to say, all right. And that's why most technicians, when they go to a site to work on a router, they already have an idea of what the different startup files are. And they got it. That's in their paperwork that they take with them, just in case they get there and that bad boy can't find the startup file. They got to build it. They got to build every port. They got to build everything on that router the way the customer wanted it built. So that's what startup mode means. You got to build it. All right.
Yeah.
Okay. Let's see. We're just about through here, guys. I just want to make sure that we got most of this. We're on 6.3.2.2, and we're getting ready to go into 6.4. Well, before we go to 6.4, we just talked about what we just said, that locating and loading it. Be sure you all read. I mean, look at the video 6.3.2.3. That's very important, so that you'll understand all these different, what setup mode does and how you go into setup mode and where you know, in case you can't find that startup file, how you will set up the. That's why it's so important for y'all to learn how to set up, configure a router, because you may have to do it several times. Okay, and now this stuff you guys already know, but I'm going to cover it real quick for you. Hopefully you know this by now. I'm going to blow it up a little bit. So you got to know your command modes. You should know your command modes. You should know what the executive user mode and what they really come down to be. And you know, your secure user mode and your the different remote telnet commands you would need to set up a telnet mode. what you would need to do an executive, enable secret password. You should know all that by now, hopefully, that you know how to do your enable secret password to secure your privilege exec mode. So that means that it needs a password, and it's encrypted. You should know how to secure your console. You got to have all three of these commands to secure a console. You got to have one behind the other. First, you got to type in the line console number, usually line console 0, and then you got to type in the word password, and then put in the password, whatever it's going to be. It's going to be Cisco or whatever that password is going to be, class, or you may put your name in, like Arthur, the password. But you type in password, then type in whatever you're going to put in as a password. Then you must put login. So many times you forget to type the word login. If you don't type the word login, it didn't save any of that stuff.
Yeah.
So you gotta type login, because login tells it that if somebody's trying to get in here, they must ask for a password before they get into the console. They gotta put in a password. That's all it's telling you. So be sure to put all three of those in there, or that console is not secure. It is not secure. And of course, we talked about how you get into your host name. The host name has got to be in which mode?
Set up configuration mode.
Configuration mode. And how do you get in configuration mode?
Oh, you talking about conf T?
Config term. Config term. That's how you get in configuration mode. And then you can then type in host name and put in the name. It'll change. But these things you got to know. I said know your modes, because they're going to ask you all kinds of questions on that, because they want to make sure that you know the modes. You've got to know the modes. Let's see. It says, what is the purpose of a default gateway? We've covered all of that. I think you guys should know about default gateway and what it's supposed to do and the purpose of it. And I understand you guys should be used to this by now, that Cisco don't ask you questions. They ask you applications of the question. So they ain't gonna ask you what's the purpose of a default gateway. They gonna give you something that you got to figure out. Is this how I use the default gateway? You understand that? That's what they do, man. They ask application type questions. They don't ask you. They may show you a picture and say, "Where's the default gateway?" So you need to get used to that, because that's the way they do things. And like I said, the last thing I just said was make sure you know your modes. You know what is the executive privilege mode, privilege executive, excuse me, and what is the secure telnet, and what is how do you get into the user exec mode, which is really you're already in it. So know your modes and know what commands you got to use for whichever mode. And like I said, that's why I gave y'all that little sheet. If you want to print that sheet out, but you need to get used to that sheet, because it tells you what mode you got to be in to use this command, and that's going to be so important.